Hello, let's continue on with SQL. Okay, so today we're going to learn about sum and all clause. Okay, so this is for set comparison. So we want to find names of instructors with salary greater than that of some. So the sum means at least one instructor in the biology department. So here we have select, distinct, T dot name. So T here is actually instructor. We just have renamed it to be T as instructor as T and then instructor as S. So we are taking a Cartesian product between instructor and instructor. Okay, so these are going to be two different instances of instructor. Okay, and the first one is T, the second one we're going to call it S. Okay, and we want to return T's name, meaning the first instance of the instructor is what we're looking for, the name of the instructors who make greater than at least one other instructor who works in the biology department. Okay, so we have T dot salary. So who we're looking for makes more than S, some other instructor. Okay, and then here it should say that S that department name is biology. So S is working at the biology department. Okay, so T dot name should be returned. Okay, here you don't have to specify that T dot name is not equal to S dot name, meaning T and S are two different people. We don't have to specify that because we have this condition where T dot salary is greater than S dot salary, meaning if they were the same people, their salary would be the same. So this would not satisfy. Okay, so that would not be returned. So there's that. We can also do the same exact query using sum clause. Okay, so we have select name from instructor where this person's salary is greater than, and then we have sum, and then we have another subquery. So this subquery will return every single salary of all the instructors who work in the biology department. Okay, so as long as this person's salary is greater than at least one of these numbers that we return, then they make more than someone from the biology. So this is also another way of doing the same exact query. Okay, so definition of sum clause. Okay, so as long as it's true for at least one of them, it will be true. Okay, so let's take a look at the first example. 5 is less than sum. So if 5 is less than at least one of these, it will be true. So is 5 less than 0? No. Is 5 less than 5? Also no. Is 5 less than 6? Yes. So it's true for at least one of them. So this whole thing is true. Here is 5 less than 0? No. Is 5 less than 5? Also no. They're the same. So this is false because none of these were true, right? Is 5 equal to 0? No. Is 5 equal to 5? Yes. So because this is true, this whole thing is true. Okay, is 5 not equal to 0? That's true. Is 5 not equal to 5? That's not true. So since it's true for this one, this whole thing becomes true. Okay, so you can also, this is kind of equivalent to in. However, not sum is not equal to not in. Okay, the next one we're going to go over is all. So this is kind of similar to sum, but except in this case, the salary here has to be greater than every single salary that was returned from this subquery. So here we're looking for names of instructors who make more than all of the instructors from the biology department. So this subquery will return a bunch of values, a bunch of numbers, which will just be a salary. Okay, and then this person has to, their salary has to be greater than every single one of those numbers that were returned. Okay? So here we have all. So when you have the keyword all, it has to be true for every single one of these values here. Okay, so is 5 less than 0? No. So here we can go ahead and stop because it doesn't matter if it's true for both of these because the first one was false, this whole thing cannot be true. So this is false. Okay, is 5 less than 6? Yes, that's true. Is 5 less than 10? Also true. So both of these are true, so the whole thing is true. Okay, is 5 equal to 4? No. So even though 5 is equal to 5 and this is true, because this one was false, the whole thing becomes false. Okay, is 5 not equal to 4? True. Is 5 not equal to 6? Also true. So both are true. So the whole thing is true. We can also check for empty sets. So we can check if something is empty or not empty. And the keyword to use for that one is exists, not exists. Okay, so we want to specify a query where we want to find all courses taught in both fall of 2017 and spring of 2018. Okay, so we want to find all courses taught in both. So it has to be taught in both of these, right? So we're selecting course ID from section SS, where semesters fall years 2017, and then we have this keyword exists. So I don't remember, but exists will exists will return true if this is not empty, meaning there's something in here. If something is returned, then that's what we want, right? So let's take a look at the subquery here. Select asterisk, meaning select everything from section. Here we had a section, we called it S. Here we're calling it T. Here we're semester, spring, and years 2018. And we want the course ID from this section and then this section to be the same. Okay, so this course ID from this one be returning all the courses that were offered in fall of 2017. This will be returning all the courses that were that were offered in spring of 2018, right? So if the course ID from S and the course ID from T are equal to each other, that means they were offered in both, okay? So we want something to be returned, okay, from here. And that's why we have exists here. We want this to be not empty. Okay, we want something to be returned here. Okay, let's take a look at not exists. Okay, so find all students who have taken all courses or every course offered in the biology department. So we did something similar in relational algebra. Whenever we saw the keyword all or every, we were using the division operator, right? So in SQL, you might find this more difficult or easier, but this is how you do it whenever you see the keyword all or every. Okay, it's going to be a combination not exists. You'll have a subquery, keyword except, and another subquery. Okay, so select distinct SID and SNAME from student as S, not exists. So not exists will return true if it's empty. We want this to be empty, right? So the parentheses following not exists, we have this outer parentheses and outer one. And within that, we have a subquery. This first set of subquery will return all the courses that are offered in the biology department. And then the second set of subquery will be returning all the courses that this particular student has taken. Okay, because we're selecting the course ID from takes as T, where the ID from T takes is equal to S.SN. Okay, so these are going to be all the courses that this particular student has taken, and these are all the courses offered in the biology department. So just to kind of explain how this works, let's say there were 4 biology courses offered, Bio 1, 2, 4, and 6. Okay, so this first one will be returning these course IDs 1, 2, 3, 4. And let's say this particular student has taken Bio 2, 4, 6, and CSC 10, right? So what this does except is it's going to take this and it's going to subtract the difference. Okay, so Bio 1 is not here, so we leave that. Bio 2 they have taken, Bio 4, Bio 6 they have taken. Okay, so we're going to be subtracting these 3 and Bio 1 will be returned, right? So this whole thing will return a single value, will be Bio 1. Okay, but when that exists, we want this to be empty, right? So let's say they have taken Bio 1 as well, right? So then if we take this and then subtract that, the set will be empty. This will return nothing, which is what we want, right? So then this will be returning those students who have taken every single course that were offered in the biology department. Okay, you can also have a subquery from the from clause. So we want to find the average instructor salaries of those departments where the department's average salary is greater than 42,000. Okay, so this can be a little bit confusing, so we're kind of breaking it down. Okay, select. Okay, we are finding the average instructor salary per department. So we're calling department name and average salary. From, and then the from clause has a subquery. So let's take a look at what's the subquery is returning in plain English. So we are looking for the department name, and then we're using an aggregate function average of the salary, and then we're going to rename to be called this from instructor, and then we're grouping by department name. So this will return every single department and then the average salary for the department, right? Okay, so that's going to be your from clause, okay, where the average salary is greater than 42,000. Okay, so this is one way of doing it. In the previous lecture, I talked about having. So here you do not need to use having. You could just use where clause. Another way of doing this is they're very similar here, but we have select department name average salary. That's the same. And then the from clause, we have not renamed this one. Okay, so we just have select department name and then average aggregate function of the salary from instructor or grouping by department name. Okay, we have not renamed it, right? But we can rename it outside of this subquery as, so now whatever this is will be called department average, and then it has two attributes. They will be called department name, and then this will be called average underscore salary, and then the where clause is the same. Okay, so you can have, this will rename just this attribute, and then this will rename this whole subquery to be called department average, as well as this attribute be called this one. Okay, we can also have a with clause. With clause provides a way of defining it's like a temporary view. When you have a really complex query, it's just easier to kind of break it down. And visually, it's just easier to see what each one is. So we're finding all departments with the maximum budget. Okay, so we're going to use a keyword with. Okay, this is a keyword, and we're going to call this max underscore budget. It has one attribute called value. Okay, so, and then we have a keyword as. So we're defining this with kind of a temporary relation. This relation is called max budget. It has one attribute called value. Okay, and then that's defined as select. Okay, we have an aggregate function max of the budget from department. Okay, so this is called max budget relation, and this max budget is called value. Okay? So you can use this max budget as if it's like another just relation. It's like a temporary relation that you just define. Okay? So we have select department.name from department name, comma, max budget. Okay, we are taking a Cartesian product between department name and then this max budget that we just defined here, where department.budget is equal to max budget dot value. So if that department's budget is equal to the maximum budget of all the departments, then we want to return the name of the department, which is what we wanted, right? So this can be useful. It's not necessary. This is not the only way to do it. If we wanted to, you could have just defined this as, you could put this in the from clause, okay, instead of having it defined as another relation. So if you didn't want to use the with, you could have just done select department name from department comma, and then instead of having max budget here, whatever you define right here, you could just put that right here in parentheses, okay, where department.budget is equal to max budget.value. So it's really up to you if you want to kind of break it out into two different steps, or you want to just include this in here into like a longer one query. Okay, if you have a really complex query, having a with clause can be very useful. So we are looking for all the departments where the total salary is greater than the average salary of the total salary at all departments. So this sounds very, we're talking about a lot of total or average different salary per department. So in this case, we know that it will be useful to use a with clause. So we're defining this temporary relation to be called department underscore total And this one has two attributes. It has department name and value. And then this is the actual definition of the relation. We want to select department name, comma, sum of the salary from instructor table grouped by department name. So this subquery will return all the department names and then the sum of everyone that works there, all the instructor's salary. So we have sum salary. Okay, and then we have another one here. Okay, department underscore total underscore average, and then this view or this temporary relation has a single attribute called value. Okay, and there you're going to select average of the value from department total, and this department total is what we just defined up here, right? So what this is doing is it's computing the average of the value, okay, for each department. Okay, so the actual query here is select department name from, we're calling department total, which is the first relation that we define. And then we're also taking a Cartesian product between that one and then department name, department total average. So we're calling these two relations that we just defined where department total dot value is greater than department total average dot value. Okay? So this will be returning the department where the total salary is greater than the average of the total salary of all of the departments. Okay. So if I hadn't used these two views here and I just, I just put in the actual definition of each one, the relation, into the from clause, this is what it would look like. Yeah, I have select department name, and then in the from clause, I have this first subquery and I have a comma, and then I have the second subquery, which is this one. Yeah, and then the where clause is the same. So you could have kind of done it like this. It's a kind of like a three-step process versus one giant one. I feel like this one, it would take you a little bit of time to kind of, think about what is this trying to do. But this one, even just the name of the relation kind of helps. Okay, this is the department and then the total that they make. Okay, and this is average. So just by looking at this, you can kind of tell what it's trying to do versus this one. I think it's just really long and messy and just more complex than it has to be. So if you have a really long, complex query, I really highly suggest that you use the with clause, which is just basically like a temporary view that you're defining. You also have scalar subquery. Okay, this is the one where is used where a single value is expected. Okay, so this query we want to list all the department names along with the number of instructors in each department. Okay, so we're selecting department name. Okay, and then we have a subquery here. Okay, we select everything from instructor where department's name is equal to instructor's name, and then as num underscore instructor, okay, from department. So there will be a runtime error if the subquery returns more than one result. You can also make modification to the database. So when you guys start your first project working in MySQL, you will, actually the second project as well, you will maybe do some of the queries where you're required to not only create a database, create tables, you have to also delete some data, some rows of data, insert new data, also make updates to certain rows of data. Okay, so delete, insert, and update. Okay, so if you want to delete all instructors, you simply just do delete from instructor. Okay, you can also specify which ones you want to delete. So delete from instructor where department name is finance. So this will delete all of the instructors who are in the finance department. Okay, this third one will delete everyone of the instructors for those instructors who are associated with the department located in the Watts building. Okay, so delete from instructor where their department name is in. Okay, remember in. Okay, so if this department name is in one of the values that were returned from the subquery, and let's take a look at the subquery. We have select department name from department where building is equal to Watson. Okay, so if the department whose building is located in Watson, it will be returned. Okay, and if that department name is mentioned, then we want to delete that particular instructor. Okay. You can also delete all instructors whose salary is less than the average salary of all the instructors. So we have delete from instructor where salary is less than, and then we have a subquery, which is basically the average salary of all the instructors. Okay? So problem here is that as we delete tuples from instructors, the average salary might change because every time you delete an instructor, their salary is also deleted. So by doing so, this average salary will be updated. The value will change, right? So if you are using SQL, first you want to compute the average salary and then find all tuples to delete. And then that's the first step. And then the next step is to delete all the following tuples found above, without having to recompute the average salary all over again, because that value might change. You can also insert new rows of data by using insert into keyword, using values. We insert into, this is the name of the table or relation, and then these are the values that you want to insert. Okay? Of course, these have to be in the same order as your attributes when you first define the table course. Here we have the course ID, the name of the course, the department, and the number of credits, right? So this is equivalent to insert into course, which has the course ID. So all you're doing is specifying the actual name of attributes, which has course ID, title, department name, and credits. But this can be skipped. So this is not totally necessary to actually show the list of attributes, but you can. We can also add a new tuple to student with total credits set to null. So some of these attributes can be null. So for example here, I guess this course doesn't really have the total number of credits. So it's going to be null because this value is unknown. Sometimes certain attributes you cannot have null. That value is important. It cannot be unknown. Something like course ID, I would say, is not null. So when you first define the relation, I would say when you define it, make sure you add that null. Okay? So that way, if you try to put in a value, insert a new value with this first one being null, it's going to give you an error, meaning you do need the course ID. Here, we're making each student in the music department who has earned more than 144 credit hours an instructor in the music department with the salary of 18,000. So we're inserting into the instructor table, okay? And then we have select, ID, name, department, and 18,000. That's going to be the salary from student, where department name is equal to music and total credits is greater than 144. Okay? You can also insert into a particular table name. Okay, select everything from a table. So select from where statement is evaluated fully before any of the results are actually inserted into the relation. Okay, so this one will cause an issue. Okay, you can also update certain values. These usually work, well with number values. Okay, so we want to give a 5% raise to all of the instructors. Doesn't matter how much they make. Everyone will get a raise. So we're doing update. This is a keyword update, and then it's used along with another keyword set. Update instructor, set salary is equal to salary times 1.05. This is a 5% raise. Okay, we want to give a 5% raise to those instructors, only those who earn less than 70,000. So we have a where clause here added where salary is less than 70,000. Here we want to give a 5% raise to instructors whose salary is less than the average. So here we would have to compute what the average is. So update instructor set salary is equal to salary times 1.05, where salary is less than, and then we have this subquery which will return the average salary from instructor. You can also have different statements, two different update statements, where those who make over 100,000 will only get a 3% raise, while others, meaning who makes 100,000 or less, will get a 5% raise. Okay, so we want to update instructor and then we want to set salary is equal to salary times 1.03. So this is the 3% raise where salary is greater than 100,000. We have another update statement who gets a 5% raise where salary is less than or equal to 100,000. So the order here is important, and this can be done better using a case statement when you guys learn programming. So I'm sure you guys know the switch case statement. Okay, so let's take a look at these examples. Now we are dealing with a new database. Okay, so we have sailors, boats, and reserves. Okay, so just for short, you can spell out the whole thing, but just because it's just easier, I just turned it into S for sailors, B for boats, and R for reserves. This is the sailor's ID, sailor's name, the sailor's rating, and their age. I have the sailor's boat ID, or the boat's boat ID, the name of the boat, and then the color of the boat. And then this reserves is this particular sailor, he reserved this particular boat's boat ID on this day. Okay, so the sailor can reserve the same boat more than once on different days. Okay? So the first one, find the colors of boats reserved by Albert. Okay, so you should also, the first thing is you should think about which one of these tables can I use to get this information. Of course, you could call every single one of those, but then it would not be very efficient. You might be calling a table that's not necessary. Okay, if you can call just 2 tables versus 3, why call all 3, right? Okay, number 2, find all IDs of sailors who have a rating of at least 8 or have reserved boat 103. Okay, and number 3, find the names of sailors who have not reserved the boat whose name contains the string storm. Order the names in ascending order. Okay, so go ahead and pause this and then take about 4 or 5 minutes per query, work on it, and then play again so you can kind of go over and compare what you have with the answer that I have. Okay, so once you're done, go ahead and click play. Okay, the first one, we want to find colors. So where can we find colors of boat? That can only be found in B, so we definitely need B. Okay, boat reserved by, so reservation information can only be found in R. Which sailor reserved which boat? So we need R by Albert. So this is a sailor's name that can only be found in S. We actually need all 3. Okay, since we're doing a Cartesian product between all 3, we will link them, right? Or else it's gonna just return every single combination, all the rows between these 3 tables, okay? So here I want to make sure that the SID, the sailor's ID from S, is equal to the SID from R, and then the boat ID from B is equal to the boat ID from R. Okay, and then we're going to be calling S, comma B, comma R. I'm going to be joining all of those. And what I want to look for here is the color. Okay, so I'm going to do select color from S, comma B, comma R, okay, where S.SID is equal to R.SID, and then B.BID is equal to R.BID. Okay, and then the last one is it's reserved by Albert, so the S name is equal to Albert. Okay, so it's not really too complex, but you just have to think about, which tables can I get this information, and then what do I have to set equal to for the predicates. And number 2, find all IDs of sailors, okay, who have a rating of at least 8. And then we also have an OR statement. Okay, so whenever you see the keyword OR, it was the keyword union, right? Okay, or have reserved boat 103. So you can kind of divide this up into 2 different subqueries. Okay, so let's first find, the first part is sailors who have a rating of at least 8. Okay, so where can we find them? A sailor's rating can be found in S. Okay, so I'm going to be selecting SID, all the sailors from S, where their rating is greater than or equal to 8, at least 8. Okay, and then we have a union, and then open up another parenthesis for the second subquery, which have reserved a boat 103. Okay, so this reservation information is in R. Okay, so I'm gonna again return the names of sailor IDs, which is return SID from R, where BID is equal to 103. Okay, so this one I think wasn't too bad. Let's take a look at number 3. So find the names of sailors who have not reserved the boat whose name contains the string storm. Okay, we want to order this in an ascending order. Okay, so let's take a look at what do we need to use for this one. This can be a little bit confusing. Okay. Here we want to make sure that the sailor has not reserved the boat whose name contains string storm. So I think using not in is a good option here. Okay, so we want to make sure that we're getting the name. So we want to get the names of sailors, which can only be found in S. So we do need to call S. Select S name from S, and then we're going to rename it to be called S1, where their ID, SID, is not in. And then let's take a look at the subquery. So what is this returning? So it's returning the SIDs from the reservation and the S sailor. Okay, of course, we want to set the SID and SID from SNR to equal to each other. Okay, and then the name of the boat that they're reserving, or actually, the boat name should contain storm. Actually, this should be B name. Okay, so B name should be like, and then we have a substring, storm, and then substring. And then we want to order by the name. Okay, so S1, okay, order by name, and it's an ascending order, so you don't have to add descending. Okay, number 4, find the sailor IDs of sailors with age over 20 who have not reserved the boat whose name includes the string thunder. Number 5, find the names of sailors who have reserved at least 2 different boats. Okay. So take about 4 to 5 minutes per query. And once you're done, you can hit play. Okay, so let's take a look at number 4. Here I have select SID from S, where the age of the salary is over 20, and their SID, so the sailor ID is not in. And then you have the subquery where select SID from R, B, the reservation and the boat, where the boat IDs are equal to each other, and then the boat name is like. So this contains thunder, so you could have something before or after or not, but it contains the string thunder. Okay. So actually, I think there was an error here. This actually, so number 3 and number 4 are very similar. Okay, it's the only thing is that this was added here. Okay, so this actually should be R and B. Okay, and then the boat name should be like, okay, name of the boat, it's not name of the sailor. And then it should have storm. Okay, and then order by, and then this should be boat name. Okay, number 5, find the names of sailors who have reserved at least 2 boats. So we're looking at 2 different instances of reservation. Okay, so we have select S name because we're looking for the name of the sailor, and then we have S, and then we have 2 different reservations. Okay, R as R1, R as R2. Here we want to make sure that the SID from R1 and the sailor are equal to each other, and then the SID from S and then R2, the second set of reservation, are also equal to each other. So this is dealing with 2 different reservations, and then it's dealing with still the same sailor because SIDs are the same. Okay, and then, but we want them to have different boat IDs, meaning this particular sailor has made different reservations, okay, but they're different boats. So here we have BID, the boat ID is not the same between R1 and R2. If you want to eliminate the duplicates, make sure you do select distinct S name.